So dear students, now let me discuss about electric field due to uniformly charged disk. Okay, so instead of ring, now let me take disk. So for disk, the charge will be distributed throughout this area. Now to find out the electric field due to the disk, we have to divide this disk into infinite number of elemental ring of radius r and with dr. And first what we have to do, we have to write down the expression for the ring, for this electric field, for the expression of ring here. So we have discussed in the last class that for ring what will be the electric field here. If you talk about for ring, E ring, okay. So if you talk about E ring, that will be dE here, that will be dE here, okay. And you know that is nothing but 1 upon 4 pi epsilon naught into qx, where q is the charge of the ring. So it will be just qx divided by x square plus r square to the power 3 by 2. So this is the electric field due to this small ring which have radius r and with dr. So it will be, instead of capital R, it will be small r, okay. So it will be just x square plus r square to the power 3 by 2. Now if we write this q in terms of charge density, then for ring we have defined earlier, for ring q is equal to lambda upon 2 pi r, sorry, lambda is equal to q upon 2 pi r, lambda is equal to q upon 2 pi r. So q we can write as lambda into 2 pi r, lambda into 2 pi r, okay. So we can write this q in terms of lambda into 2 pi r. So it will be 1 upon 4 pi epsilon naught, okay, into lambda into 2 pi r into x divided by x square plus r square to the power 3 by 2. So this is dE, okay. Now for whole ring we have infinite number of ring, and the ring will be the very first ring will be for r is equal to 0, then there is some r, then there is another r. So r will be increasing from 0 to capital R. So the whole disk will be covered. So we have taken one of that ring which has radius r and with dr. So if this disk has charge density sigma, okay. So if the sigma is the charge density of charge per unit area, that is charge density of disk. Let me take sigma as charge density, but this charge density is for disk. So if this sigma is the charge density for disk, then what will be the charge on the ring? So we can express the charge of the ring, okay, which have with dr in terms of sigma also. So how we can write down? So for ring the charge will be what? Lambda into 2 pi r. If you talk about the ring, so for this ring the charge will be lambda into 2 pi r. This is the charge. But if you talk about in terms of surface charge density, then what is the area of this elemental ring of radius r and with dr? So the area of this elemental ring will be 2 pi r dr, as this width is dr, so it will be just 2 pi r dr. So 2 pi r dr is the area, and charge per unit area is sigma. So total charge will be sigma into 2 pi r dr. So in one respect you can write the charge on the ring is sigma into 2 pi r dr, and on another respect you can write that it is lambda into 2 pi r. So you can substitute here for this lambda into 2 pi r, we can substitute as sigma into 2 pi r dr, or you can simply write as lambda is equal to sigma dr, lambda is equal to sigma dr. So you can put here, so this will be just 1 by 4 pi epsilon naught into 2 pi r into sigma dr, 2 pi r into x, okay, into sigma dr divided by x square plus r square to the power 3 by 2. So here r is variable, okay. So total electric field at this point P, so we have to integrate this expression, okay. So what will be the net electric field? So net electric field, we can write that net electric field at P will be E is equal to integration d so it will be integration d. Now you can see which are constants. So this x, 2 pi, these are constant actually. The only variable is r, because the integration will be on r. So r is the variable, but x is the finite distance, fixed distance. So we have to write here, just we can write 2 pi x sigma divided by 4 pi epsilon naught, and within integration we can write as r dr divided by x square plus r square to the power 3 by 2, and in that case my r will vary from 0 to capital R. So this will be the final expression, and we have to integrate this expression. So you can see here this 2 pi and this 4 pi will be cancelled out, so it will be just sigma x by epsilon 0. Okay, so we can write this as sigma only, sigma x by 2 epsilon 0. So it will be just sigma x by 2 epsilon 0. And now if we want to integrate this expression, then what will be this? So let me put x square plus r square is equal to t square. So if we put that x square plus r square is equal to t square, then we have just r dr is equal to t dt. So r dr is equal to t dt. Okay, so it will be just sigma upon sigma x upon 2 epsilon 0 into, so in that case if you take x is equal to 0 or r is equal to 0, okay, so here r is equal to 0, so t will be x. So now the limit will be from x to, and where small r is equal to capital R, then it will be root x square plus r square. So it will be root x square plus r square, and this r dr means t dt, and t square to the power 3 by 2. So t square to the power 3 by 2 will be t cube, and here is t, so it will be t square. So dt by t square, it will be like this. Let me write down. So it will be t dt divided by t square to the power 3 by 2, that means t cube. Okay. So now if we integrate this expression, we will get, so now let me integrate this expression here. Okay. So let me integrate. So it will be just, so e will be now 1 by sigma x by 2 epsilon 0, and it will be 1 by t square, and integration of 1 by t square is minus 1 by t, and the limit will be from x to root x square plus r square, So now we can put the limit. So here is minus sign, so we can take lower limit first. So it will be sigma x upon 2 epsilon naught into 1 by x minus 1 by root x square plus r square. Now if you want, you can take this x inside, so you will get a very good expression, that is sigma upon 2 epsilon naught into, if you multiply x here, so it will be 1 minus x divided by root x square plus r square. So this will be your final expression of electric field at axial point x for the ring, for the disc. Okay, and this is a very good expression, and we can analysis this expression. Okay, and you will get some good information from here. So now let me analysis this expression. Okay, so from here first we can find out the electric field at the center. So at center x will be 0. So if you put x is equal to 0, then you will get E is equal to sigma upon 2 epsilon 0, and that is constant here. So throughout the disk the electric field will be constant, and we can prove this result by using Gauss law also, that at a very near point of this disk, when x tends to 0, that means very near point. So at very near point of this disk, the electric field will be sigma upon 2 epsilon 0. We will prove later on. Okay, by using Gauss law also. So here you can see at x is equal to 0, you can write at x is equal to 0, E will be at center, and that will be maximum, that is sigma upon 2 epsilon 0, and that is maximum value. Why that is maximum value? Because you know, if for any value of x, so it will be subtracted from 1. so it will be less than this. So when x is equal to 0, so this value sigma upon 2 epsilon 0 is maximum. And where the field will be minimum? When x tends to infinity. So when x tends to infinity, this field will be minimum. So at x tends to infinity, you can say, at x tends to infinity, okay, your E tends to 0, E tends to 0, okay, so that will be minimum. So you can write it in this way also. So we can draw the graph, E versus x graph. If you want, you can draw the E versus x graph also here. So if this is E and this is x, then you can draw the graph this direction. So at x is equal to 0, it will be maximum, and then it will be minimum where it will be when x tends to infinity. So this is E max. And if you want, you can draw the graph from negative x axis also. So if you draw the graph in this side, then your electric field will be along this side. So you will get maximum here, and the graph will be like this. So if you want to draw the graph on negative x axis, you can do also. Okay, so this is something like this. And why I am saying that it will be minus, because when you talk about the field on this side, okay, then the direction will be along this side. So here at this point, the direction will be along this point. So if you take this as x axis, so your electric field will be, E vector will be this, you can write it as I cap. But you take the point P as here, so it will be minus I cap. And that's why the electric field, the graph shows these things actually. So at x is equal to 0, you will get E here if you are along positive x direction. If you want to go from here to positive x direction, and if you want to go to negative x direction here, so you have to find out, you have to put the electric field here at x is equal to 0. Okay, then you will see the graph something like this, and for this direction you will see the graph something like this. So this is the whole analysis for electric field due to the charge disk. Okay, and the others continuous charge distribution we will discuss on Gauss law. Okay, like charge sphere, uniformly charged sphere, charge cylinder, etc. we will discuss in Gauss law, because they are more symmetric case, so our calculation will be little easy if you calculate this electric field due to that charge distribution by using Gauss law. Okay, thank you.